Okay, Isosceles triangles day 2. What you should have gotten from yesterday basically was that an isosceles triangle has two equal angles. The angles still add up to 180 degrees, so you can kind of play around with the 180 degrees and the fact that two of them are the same and kind of figure out what's what when it comes to the triangle. However, that's not the only property that an isosceles triangle has. It's very closely related. Whereas like we had two equal angles in the triangle, well, you also have two equal sides, and those kind of go hand in hand. As a matter of fact, if you go back and look at that homework, the angles, the assignment where I was asking you about angle measures, there was always sides that were marked as being equal. It goes hand in hand. With the sides being the same, I know that these angles down here are the same and vice versa. If I know these angles are the same, I know the sides that come off of them are the same. So you could have either one of them marked and be asked about the other one. Like I could mark the sides and ask you about the angles. I could mark the angles and ask you about the sides. It's the same property. So you kind of need to be able to realize that, hey, these sides and these angles go together. The difference is sides never add up to a magic number. So like whereas the angles always added up to 180 degrees, the sides are just sides. That actually might make it a little bit easier. But before we get into the sides, I wanted to real quick run over what we did yesterday. So you've got one angle's 47. What's the other angle? All right, different question, but pretty much the same thing. However, I'm asking you for this angle measure at the top. Now, since this angle down here is 70 degrees, look at the side. I know that this angle up here, look at the side, is the same as the first one. So that one's also 70 degrees. But what's the measure of angle X? All right, last question like this, and then we're moving on. I want to know what this angle is down here. This angle is the same as this angle. So I actually have two of these that I could label with an X. But they still have to add up, the three of them have to add up to 180 degrees. So if I take that 50 degrees out, that leaves me 130 degrees that I have to split equally between those two angles. What does each one of those angles have to measure? All right, moving on with the sides. In these triangles, I don't know why my picture's moved on me, but in these triangles, again, I have these equal angles down here at the bottom. Right, I've got these angles marked. That means that these sides off of those angles are the same measure. So what that's going to allow us to do is set up a very straightforward equation that says, hey, this left-hand side, that's the same as the side on the bottom, and then you solve it. Okay, these aren't going to be big, difficult equations to solve. They're going to be quite possibly the simplest equations you've had to solve in algebra. So I'm going to take 2x minus 4 equal to 12, solve it. Add the 4, divide by 2. Okay, these aren't going to get much more difficult. They're like I said, pretty straightforward, probably the simplest equations you've solved in algebra. Once you get this set up, solve it. Again, the left side equals the right side. Okay, get it set up, solve it. Now, this last one here, the fact that your x has a negative value, usually negatives, when you start talking about geometry, negatives kind of throw up some red flags, but it is a negative value. If you were to plug it back in, you're still going to get a positive length out of that. The solutions, the variables being negative themselves isn't really that big of a deal if you keep that in mind. You're going to plug this back in and do some math with it. That might make it positive where everything's okay.